students, I'm Nilanjana Sunyal. Welcome you all to my channel in this online math classes. Our today's topic is solving a rational inequality when the other side is not a zero, not equal to zero. Now in our previous two sessions we have learned how to solve a rational inequality using the number line method and using the algebraic method. But in the previous two sessions, the other side of the inequality was containing a zero. One side was containing the rational expression and the other side was containing a zero. But in our today's session, the other side will be a non-zero number. Now, you may be thinking that I have not mentioned the method for our today's session. Yes, I did not mention any method because actually you will be needing just one more step to make the inequality have the other side equal to zero. That is the only extra step that will be required. And as soon as you get the other side as zero, you may use the number line method or you may use the algebraic method for solving the given rational inequality. Therefore, I have not mentioned any method in the heading, though I will be using the algebraic method in our today's session. You may use the number line method as well. We will just be needing a single step to make the other side equal to zero. Okay? So without any further delay, let us start with our today's session. Let us first of all look at the given rational inequality. The question says find the solution set of x where x plus 3 over 6 minus x is greater than 2. This is the rational expression on the left hand side of the inequality, and this 2 is the non-zero number which is present on the other side or the right hand side of the inequality. So now let us move on to the rules part. Rule number 1 says bring the number of the other side to the side of the rational expression and simplify to have a common denominator. The other side becomes a zero. I have written bring the number of the other side, that means bring this 2 to this side, the left hand side. If you consider this to be meaningless, of course it is meaningless, and I have repeatedly said that this is just a shortcut form of seeing things. Actually what we are doing is we are adding negative 2 to both the sides. If we add negative 2 to both the sides, the right side becomes 2 minus 2 equal to 0 and the left side becomes x plus 3 over 6 minus x minus 2. Okay? So this is what we get. We have brought this to this side, 2 to this side, or we have added negative 2 to both the sides. So we are having this type of an inequality where we have made the other side a zero, have a zero number. Okay, it is equal to 0. The only difference with the previous inequalities that we had is that now we are having two terms on the left side. In our previous sessions, we had the 0 on the right side, but we had only the rational expression, a single term on the left hand side. This is 0 on the right side over here, but we are having two terms on the left hand side instead of one. Okay, so what do? We will be simplifying to have a common denominator. X plus 3 is having this denominator of 6 minus x, but this negative 2 is having a denominator of 1. We have to make the denominator equal to 6 minus x. So we will be multiplying negative 2 with 6 minus x and 1 with 6 minus x. So we get 6 minus x and we write x plus 3, and negative 2 multiplied with x, 6 will be giving us negative 12, and negative 2 multiplied with negative x is plus 2x. This is greater than 0. Now we simplify the numerator because it is containing some like terms. X plus 2x will be giving us 3x, and 3 minus 12 is 9. So 3x minus 9 over 6 minus x is greater than 0. Now we are having one rational expression on the left side and a 0 on the right side. And of course you may take out this 3, the common factor from these two terms, and you may have 3 and within parenthesis x minus 3. And you can divide both the sides by 3. That can also be done. I have not done that part, but if you want, you may do it. And now this is of our known form. Now from this step, you can use the number line method or you may use the algebraic method to solve this rational inequality. I will be using the algebraic method in our today's session. Okay. So, rule number 2 says, consider the two cases of the denominator being a positive and a negative number separately if it is not a perfect square. 6 minus 6 is definitely not a perfect square. We do not know anything about this. It may be a perfect square, may not be a perfect square. We do not know. It may be a positive number, it may be a negative number, but can it be equal to 0? No, it cannot be equal to 0 because we cannot have a 0 in the denominator. So, 6 minus x will not be equal to 0. The only two possibilities that we are having is 6 minus x is a positive number or 6 minus x is a negative number, and we will be considering these two possibilities separately. Okay. So, case 1. 6 minus x is greater than 0. We are taking 6 minus x to be a positive number. Okay. And from this, we are getting the solution set of x as x is less than 6. And why do we need this? Because we want to get rid of this fraction form. We will be multiplying both the sides of this given inequality by this 6 minus x, the denominator expression, so that we can get rid of the fraction form. Okay. So multiply, rule number 3 says multiply both sides by the denominator expression to get rid of the fraction. The inequality sign gets changed when the denominator is a negative number, but in our case, case 1, we have considered 6 minus x to be a positive number. It is greater than 0. So on multiplication of 6 minus x to both the sides, the inequality sign will not be changing. Okay. So we are multiplying both sides by 6 minus x, and this denominator 6 minus x expression and this 6 minus x of the numerator, they will be cancelling each other, and 0 times 6 minus x is 0. So the inequality becomes 3x minus 9 is greater than 0, from this inequality we get the solution set as x is greater than 3. But we cannot ignore this solution set because we have considered 6 minus x greater than 0. That is why the inequality sign did not change. So this inequality, this solution set should be combined with this solution set. X should be a real number which will be less than 6 but will be greater than 3. And of course we can find a real number. In fact, we can find infinite number of real numbers for x which will be greater than 3 but will be less than 6. You may have 4, you may have 5, you may have 3.5, you may have infinite number of real numbers between these two numbers 3 and 6. So this is a valid inequality. So I have put a tick across this solution set. Okay. Now coming to case number 2, where 6 minus x is considered to be a negative number, that is 6 minus x is less than 0. From this inequality, we are getting the solution set of x as x is greater than 6. Again, we will be doing the same thing. We will be multiplying both the sides by 6 minus x because we want to get rid of the fraction. But you see, since we are multiplying with a negative number, this time we are considering 6 minus x as a negative number. Since we are multiplying both sides of the inequality by a negative number, the greater than sign is getting changed to less than sign. The inequality sign is getting changed in this case. Okay? And now the numerator and the denominator 6 minus x will be cancelling each other. Okay? And we have 3x minus 9 is less than 0. So from this we get the solution set of x as x is less than 3. And again we have to combine these two. X will be a real number which will be simultaneously greater than 6 and less than 3. Can we have any real number which will be simultaneously greater than 6 and less than 3? Definitely not. So this is a perfect cross. We are not having a valid solution set. These two are totally incompatible. A number cannot be simultaneously greater than 6 and less than 3. Okay? So rule number 4. Select the inequality from the two cases for the final solution set. Now we are having two cases and we have got two solution sets. But it is not that we are having a tick for both of them. If we have a tick for both of them, we have to consider what will be the common solution set. But over here we are seeing that we are having only one tick. This cannot be taken. So this will be the answer. This will be the final solution set. So therefore x is a number. X will be any real number which will be greater than 3 but will be less than 6 to satisfy this given inequality. X plus 3 over 6 minus x is greater than 2. So this is our final answer. X is greater than 3 but is less than 6. Okay. So students, this brings us to the end of this session. Please like, share and subscribe if you find this video helpful. Thank you for watching this video till the end. We meet again very soon. Till then, bye.